Hi everyone, welcome to Raaonline Biochemistry. This is Dr. Srivatsan, your faculty for biochemistry. Okay, so in this session we will be seeing about enzyme inhibitors. So this is an important topic in the context of both as well as for your exams during the first year MBBS as well as during your post graduation entrance examination as well as in FMG examinations also, because lots and lots of high yield questions are being asked each and every year, and for the person, for those who set the papers, actually this is one of the favorite topic. So please listen to me carefully regarding the enzyme inhibitors. This may look slightly confusing, and I will try to clear all the concepts first. So in this thing I will be discussing only with regards to the Lineweaver-Burke plot, because it is easy to understand with the help of a Lineweaver-Burke plot instead of a conventional plot. And I have discussed the significance of usage of Lineweaver-Burke plot in another session regarding the various kinds of kinetics, enzyme kinetics. So with this, we just move on into our today's topic of enzyme inhibitors. So what do you mean by a term inhibitor? What is the role of an enzyme first? So enzymes, what it does, these are actually biocatalysts. They help in conversion of a substrate to some kind of a product. Okay, so how it does that? It does that kind of a conversion from substrate to product by decreasing the amount of activation energy. So what is the role of inhibitors here? Inhibitors are the one which actually inhibit the function of the enzyme so that they inhibit the formation of product itself. So this inhibitor can have various mechanisms on acting upon the enzyme. So with respect to all these kind of various mechanisms, we can have various kinds of classification with regards to the enzyme inhibitors. So as of now, the enzyme inhibitors can be broadly classified into two major types. The first type will be reversible inhibition, and the second one will be irreversible inhibition. So the name itself says, what do you mean by reversible? You can reverse the reaction by removing the you can carry on the reaction forward by removing the inhibitor. In case of irreversible, you can't do anything much. So this is how you broadly classify the enzyme inhibition into two types. Okay, now this reversible inhibition can further be classified into three types. Okay, the first one is competitive. The first one is competitive inhibition. The second one is uncompetitive inhibition. Remember the name, this is not non-competitive inhibition, this is uncompetitive inhibition. Okay, the third one is mixed inhibition. So reversible inhibition can be further classified, subclassified into three major types. One is competitive inhibition, the second one is uncompetitive inhibition, and the third one is mixed inhibition. Now we will see the details of each one of these kind of inhibitors with the changes occurring in the kinetics as well as various kinds of corresponding examples with regards to these kind of inhibitors. Clear? Now we will start with competitive inhibition. So what do you mean by competitive inhibition? In case of competitive inhibition, the inhibitor will be a substrate analog. They closely resemble to that of the substrate. See, this is the reaction, right? Enzyme plus substrate, you get to form enzyme substrate complex. This is the higher energy state. From this, you release the product. P is product. Clear? So, this complex is formed, right? Now, in case of inhibitor, what happens? This inhibitor closely resembles to that of this substrate. Okay. So, because of this, what happens? They also tries to go and bind to the catalytic site of the enzyme where the substrate usually binds. Usually, in order for the reaction to go forward, what should have to happen? The substrate has to go and bind on the catalytic site of the enzyme. This results in the formation of enzyme substrate complex, and finally the reaction occurs, enzyme gets removed out, and finally the product is getting formed. Okay. So, this is how a normal reaction takes place in the presence of an enzyme. Now, if we have a competitive inhibitor here, what it does? It just goes and it tries to compete with the substrate for the same catalytic site. So, the enzyme catalytic site is there. This inhibitor is just going to compete with that of the substrate for that exact catalytic site itself. So, because of this catalysis, what happens? There will be formation of enzyme inhibitor complexes. Which cannot progress to product. You get the point? So, this goes and totally disrupts the role of substrate there. Okay. This goes and hinders the substrate binding with that of the catalytic site of the enzyme. So, because of this, instead of ES complex, you get to have EI complexes, and this EI complex is not going to produce any kind of a product. Okay. So, this is how a competitive inhibitor will function. Are you clear with this concept, guys? Right. Now, what happens if you try to increase the substrate concentration? Anybody? Any idea what happens in that case?